Good afternoon, everyone. My name is Rupinder Jawanda, and I'm a Senior Program Manager in SQL Server. Today's talk is about the Columnstore Index performance tuning. You'll notice the name is slightly different. This is our new marketing term for the Columnstore Index. So it seems a little bit different than what the original title was. Hello. I'm thrilled to be here today to give you this talk because I've seen some of the performance results for queries running in the 15 to 20 minute range coming down to less than 10 seconds. And the results are pretty dramatic. Before we get too far into the talk, just with a show of hands, how many people are familiar with the Columnstore technology? Quite a few. Now, has anyone actually put it on a table and tried it, either in a staging or production? Okay, wonderful. That's more than other talks, so that's great. So this is a 400 level deep dive, so we are going to get into some workarounds, some code issues, and some limitations with the index. So let's get started. First, the two main session objectives is to get one, outstanding performance using the Columnstore index, and two, we're going to talk about how to load your Columnstore table. Because effectively, when you put the index on the table, it becomes read-only, and we're going to talk about some different methods on how do we actually update the data. We're also going to talk about good application design and the batch mode, which is our new query processing execution mode. This mode actually saves us a lot of CPU cycles and gets us faster query performance. And feel free to ask questions at the start, and we'll have time at the end. So why is this important? So if you put the Columnstore index on the table, you'll get good performance. But if you can fine-tune your application, if you can use some of the workarounds we're going to talk about today, and if you can run it in batch mode, you will see the amazing performance we're seeing in our labs and with our few customers that we've been working with so far. Today we're going to cover an overview of the Columnstore index. This will be good for just giving context for people who aren't familiar with it. We're not going to spend too long on it, but it will help. We're going to talk about workarounds. Certain things like outer joins exist, and they do not work in batch mode right now. So we're going to talk about how do we get those to work better. What can we do differently? We're going to talk about loading the tables once you've applied the Columnstore index on it. We're going to talk about optimizing the database design and index management. We're going to get into some of the memory issues that people are experiencing. And we're going to talk about data reduction through segment elimination. First, I'm just going to show you a short query here. This is our Movlia. It's a movie database. It's a demo database we use. It's a star join. It has a fact table, the purchase fact table, which has roughly 101 million rows. So, just getting it started. I am going to run the query with ignoring the Columnstore that I've placed on it first. And I hope everyone can see that. The room is fairly shallow, so everyone should see that. Now, just one thing to note, the purchase table over here, it has a clustered date index, and it has the new non-clustered Columnstore index that I put on the table, and I included every column in the table when I created that. And this ran in roughly 15 seconds when we did not use the Columnstore index. Now, when I run it with the Columnstore index, it returns in less than a second. Let's take a look at the plan. For those of you who haven't seen it before, that is the new symbol for the Columnstore index scan. And this is our new batch execution mode. And this tells you that yes, you're running with the Columnstore index, and yes, it's running in batch mode, rather than the existing query execution mode, which is our row mode. So that was just a brief demo to show you some of the performance gains that we're seeing. Obviously, I picked a small example so it would fit quickly. So now we're going to go into an overview of the Columnstore index. So typical database management systems, they organize the row store data into heaps and B trees, and that data gets stored row-wise contiguously on the pages. Now we've kind of flipped that idea, and we're putting the column data and storing it on the page contiguously. Now the big advantage we've seen is compression. So when we do column compression, it's the same data type, just different values. We're getting about 2 times better than regular page compression with a row, where the row you have multiple different data types, different values. The other big advantage we're seeing is we only fetch the columns we need. So an example, say your table has 20 or 30 columns, but your query only accesses about 5 of them. You would only bring those 5 columns into memory. Those column segments, only 5 of them would come into memory, and this dramatically reduces the I/O. Now what does it look like? So the first thing is we create the row groups. We horizontally partition the data. Row groups are a million rows per row group. Then within those row groups, we vertically partition the data into column segments. Now each segment is compressed, which we just talked about, and it's stored in a separate log. And it is the column segments that are brought into memory. So in the previous example, those 5 columns we need, we would bring those 5 segments into memory. And now this is just a short illustration of how it works. So this is your table in row format. It's a standard fact table. It has the order date key, etc. First, we horizontally partition them into row groups. And again, this is a million rows in each row group. I'm not sure if I said 1,000,000 or 1,000 earlier, but it is 1,000,000 rows in each row group. If your table has less than 1,000,000 rows, it will just be one row group. And that number is set. It can't be changed. In this example, it's just 6 for our purposes. And, oh, sorry.
Can I just ask, what's the thinking of doing it as 1,000,000? What reason?
I think we've had these discussions on whether we should change that value or let the customer change it. We picked 1,000,000 because we were taking large fact tables to begin with, and we just did them in 1,000,000 row chunks, and we noticed that we were getting great performance. If we were to go down a couple 100,000 or up or change that, we could look at that in the future, and we've had those discussions.
Did you see the performance change based on the amount of data per row?
That's what I'm, not necessarily, no. No, we didn't. One other thing I just want to show you is the Columnstore doesn't sort the data itself. If you look at the order date key, you got the 07s, 08s, 09s. This index is actually built off the clustered index, which is on the date. And that's kind of important because later when you look at segment elimination, it's based on whatever index you build it off of. And we'll get into that in a few minutes. So first we created the row groups. Now we're vertically partitioning into column segments. So across 2 row groups here, we're going to have roughly 6 segments each, so 12 in total. Now we compress each segment, and each segment will compress at a different rate because each column has a different data type and different data values. Now here, so in my select statement, I'm only grabbing 3 columns. So I would only need those 3 column segments to go into memory. And it would be across all row groups. I would only take those 3. So I wouldn't need the other 3. And that's how we save pretty dramatically on I/O costs. And before we get into batch mode, was there any just general questions on how we're doing it for the Columnstore? Sorry, what kind of?
At what time does the data get loaded?
We're going to get into that in a little bit further. We're going to talk about segment elimination, and let me know if I don't cover that. So batch mode. This is our new query execution mode. This is different than the old one where we had the row mode, where one row goes through the query plan operators at a time. This is a huge change in SQL Server query processing. This is pretty dramatic. So instead, the Columnstore data is going to move a batch, which is roughly 1,000 rows, at a time through the query plan operators. And our query execution team has spent quite a great deal of time on making this very efficient. They've reduced the overheads of the row within the batch. They've reduced the instructions per row. They have focused on better parallelism. They've eliminated some of the exchange operators, which has actually made the query processing go a lot faster. And they've actually were able to utilize the cache better. And actually a lot of it fits in the L1 cache. Now what does it look like? It is one vector per column. Again, we process roughly 1,000 rows at a time. And we implemented filter, hash join, and hash aggregation, specifically on the vectors. And this has reduced the CPU time from 7 to 40 times, which is pretty huge. So first we talked about the column segments and bringing those into memory. Those reduce the I/O. And now we're talked about reducing the CPU cycles. So the first takeaway would be when you are utilizing the Columnstore index, if you can get your queries to run in batch mode, they will run a lot faster than running in the traditional row mode. Yes? We're going to go through some of the issues right now. So we're going to talk about some workarounds with some of the issues within exists, outer join, that do not run in batch mode. And so I'm kind of going to go through examples for you. So first, best practices, use a star schema. This is our sweet spot. So if you have queries that you can use the group by, if you have star joins, these will work really well with the Columnstore index. Put the Columnstore on your large fact tables. This is not meant to be put on every dimension table. And when you're creating it, include every column of the table. And we're suggesting using integer surrogate keys for joins rather than strings. There's issue with strings on the joining and the filtering. And that goes into things to avoid, joining and filtering on strings. Also, joining pairs of very large tables. So if you were to look at like an orders and line item from TPCH, you wouldn't want to join those two. They would not run in batch mode. And now we're going to get into some of the workarounds for in, outer join, and union all, which do not consistently run in batch mode. So again, we're using our movie database. We're using our purchase fact table. And I'm just going to make that a little larger. It's in left outer join. And I'm going to run that and show you what's happening there. So this is going to take a little while. This is not running in batch mode. This is running in the traditional row mode. And it took roughly 7 seconds. And I'm just going to show you what the plan looks like. So we have our Columnstore index scan, but here, if we can see it, it's actually running in row mode. And that's why it's not returning in less than a second. So the key is, how do we get this to run in batch mode? So the suggestion is, if you can rewrite your outer join query, and even if a portion of it can be run as an inner join, it will run faster because that portion will run in batch mode. And if you can get the number of rows to be reduced enough, even if you're running in row mode, it'll be on such a small amount of rows, it will still run fast. So for instance, if I run this, that's just a section of our rewrite, but that runs in less than a second. So when I run the rewritten query, that it is there. It returns in less than a second. And it's the same query that was the one I showed you earlier that ran, I think, in 6-7 seconds. So another example is in and exists. In with a subquery does not run in batch mode. Same with exists with a subquery does not run in batch mode. So here I'm just creating a table called Media Study Group. It's just built off of, it's taking the top 1,000 rows from the media dimension. And now I'm going to run just a regular, let me make this a little larger for you. I'm just going to run a regular select statement with an in. And it's going to look for that media ID in that group that I just created. And when we run this, it is not running in batch mode. It takes about 5 seconds. Now the equivalent query with an exists also does not run in batch mode, and that'll take about 5 seconds as well. However, we rewrote the query to use an inner join. Whoops. So that's the query that we've rewritten. And when we run that, that comes back in less than a second. So really the key would be for the in and exists, if you can rewrite it into an inner join. Inner join works really well with the column store index in batch mode. However, one little gotcha. In with a list of constants, and I have run this with up to 100 constants, it runs in batch mode as well. So this is not with a subquery, but it's in with constants, and this runs in less than a second. So we're going to do a few more examples, but I'm just going to switch back. So outer join, we talked about if you can rewrite any portion of that join into an inner join, it will run faster. Even if you can't write all of it, if you can get a portion, it'll work well. In and exists with subqueries do not run in batch mode. In with a list of constants will. Union all. Union all is one that does not consistently run in batch mode. I'm going to show you some examples here. Again, I'm using the same purchase fact table, 101 million rows, and this is all running off my laptop. So here I'm just creating a delta purchase table, and I'm just putting one row in there, and it's coming from the purchase fact table. And I'm creating a view. And the view I'm creating is I'm selecting directly off the purchase table, and I'm doing a union all directly off the delta purchase table. And now here, I'm doing a select statement. Whoops, let me just redo that here. I'm doing a select statement with, there's the purchase view, and I'm just adding one dimension, and it's just date. It's a very simple, straightforward query. So it ran in batch mode and returned in less than a second. So this was a union all directly off the fact table and the delta purchase table. And it ran in batch mode. Now, however, I am going to, all I'm doing is I'm adding one more dimension, media, and it's not that large. And I'm taking the column genre from it. I'm going to run that. And that actually now goes into row mode, and it'll take about 30 seconds. It's not executing in batch mode. It's that small addition of one more small dimension and one more column that took it out of batch mode. So while this is running, I'm just going to switch back to the presentation. That'll take about 30 seconds. So the suggested workaround to consistently get the column store index on a union all to run in batch mode is to push the logic on each table and get it to, so you push the logic on the delta table and the delta purchase table, and you union all the output of both of them. Then you do a group by. This is called local global aggregation, and I'm going to show you a very simple example of it. So that query did return. It did take the full 30 seconds. So now I'm going to show you a different way to do this. So here we're going to write the separate query. using our purchase table. Oh, yes, sorry. I thought I was on the wrong one. Yes, so we're writing our query off the purchase table using the date and using the media dimension, and we're putting the output into main summary. And when I run that, it runs in less than a second. Now I'm going to do the same query and put it in the delta summary. So here I have the same query. Now I'm using the delta purchase table, and I'm putting it in delta summary. So I'm running the query on each of those tables and putting them into these different summaries. And again, when I run this, it runs in less than a second. It only has one row in it. Then I'm going to combine it and do a union all from the two summaries, and then do the group by. So when I break out the logic and run it, it returns in less than a second. So if you can break out the logic, run it on each individual table, do a union all across the output, and then do the group by, it breaks it down and runs in batch mode, and it returned in a second as opposed to the 30 seconds. So next one. Scalar aggregates. So scalar aggregates are aggregates without a group by clause. This is actually a bit of an issue with performance. Select count from purchase takes 1.2 seconds. Such a simple statement, it should run faster. But unfortunately, we don't have it running in batch mode right now. The workaround is to write this more complicated query. It has a couple levels of aggregation and a group by, but it returns in 1/10 of a second. So the only workaround at this point, and I know it's a bit of a quirk, and we are working on all these workarounds that we started with, we're working on them, but for the version that's the V1 for Columnstore Index, this is a bit of a quirk. And we have more examples. If you were to Bing Columnstore FAQs, it comes up first on the search, and we have more examples written there that you might find useful. Multiple distinct eggs. So in general, these don't run great performance-wise with the row store or the column store because they generate a table spool. And a spool is when you have a query plan and you have a subquery in there, and it needs to, it puts the results, the temporary results, into an internal table. And then the rest of the query plan continues and goes back and accesses those results from the spool. Unfortunately, the spool write and read is single-threaded. So it's a bit of a performance bottleneck. But the workaround is to actually, instead of having the multiple eggs in one query, if you can break them out and then join the results on the grouping key, you'll see much better performance. I'm going to show you an example of that. So here we are going to run a query. Here's the one egg, and then here's the other one. And we're going to run them. They're all combined right now. And this will take about, I've got it around 17-20 seconds. And the workaround, while that one's still running, is to actually break it down into separate queries. So this would be the query for media ID count. Oh, it just returned in 18 seconds. So this would be the query for media ID count, and then if we were to break it out and have another query for the other one, and then we join the results on the grouping key. So the first time we ran it, it took 18 seconds. And there we go, it took less than 1 second. This is actually doing 2 full scans and in batch mode, and that still runs faster than running it together in row mode. Also, in SQL Server 2012, running queries with one distinct egg and one or more non-distinct eggs, it runs without any spool. So this is in the 2012 RTM that was already released. So that should help with performance as well on queries. Were there any questions on any of those workarounds that we went through? Sure.
Are these things in books online?
Sorry, are the...
Are these things documented in books online? The issues and workarounds?
I'm not sure about the books online, but they are on our TechNet wiki. They are. Actually, all of these are. And some of the examples are similar. And there's even more. So we're going to get into how to load the Columnstore effectively. So once you put a Columnstore index on the table in essence becomes read-only. You cannot merge, you cannot insert, update, or delete. So we're going to talk about 3 different methods for how do we get new data into this table. The first is the standard, you got to drop your index, update the table, and then rebuild the index. Now the pros with this one is if you have a nightly load window, this will work well. It's straightforward, the steps are easy and known. The biggest problem is the rebuilding the Columnstore index. It takes about 2 times longer than a B-tree index. So that can be a fair amount of time. It can work well if you have a nightly window, but it will take some time. The other option now is using partition switching. So the column store must be partition aligned with the underlying storage structure of the B-tree or heap. And to add data daily, for instance, you would partition by day, and at the end of the data, you would add an empty partition. You would split that partition, and then you'd create a staging table and update your data there, create the column store index on that, and then switch it into the empty partition. That would be if you wanted to add brand new data in. This is faster than the previous one where you had to drop it, change your data, and then rebuild it. However, you still have the cost of the partition switching. The third option is the union all. So this is the example that we went through just a few minutes ago with the delta and delta purchase table. You can use the local global aggregation workaround we talked about where you run the logic on each individual table. You do the union all on the output, and then you do your group by. And this is good for a trickle or if you want to just bring in a little bit of data, but you're not actually putting it into the table, you're just querying across the 2 sources. Was there any questions on the different options around loading the column store index? Yes. Yes. No, it's the same. Yes. Yes.
What about the query performance for the 3 times? So are there any considerations that my queries will be slower or faster?
Your queries will not be slower across any of them, especially when you just drop and rebuild. Also with the partition switching. And I just gave you an example of the union all, where you were loading with the really large 101 million records in there, and then the delta purchase. So the performance should be the same. It's just a matter of how your system runs and whether you have that nightly window, can you run, this process during it. Nobody asked, but we are working on an updatable column store index. We haven't got the official release date, but it is in progress. So optimizing index management and database design. So reduce your non-clustered B trees. The best way to explain this one is to give you a customer example. So we had a customer in the lab, and they came to us and they said, look, our query is taking 17 minutes. Can you help us put a column store index on it and bring down the time? So we put the column store index on. We went from roughly 17 minutes down to 5. And then we were it should actually go a lot faster. That's a pretty good gain, but with this new batch mode, it should be running a lot better. And when we dug into a lot of the query plans, we noticed that the optimizer, so with this particular table, let me just state, it was a fact table that had 2 billion records in it, 2 billion rows, and it had 5 covering B trees. So if there was roughly 20, 30 columns in this table, they had an index on 5 or 6 rows. They had another index on 20 rows. So there was a lot of covering B tree indexes. Now the problem with that is the optimizer didn't handle that case very well, and the plans that were generated were not good plans. So once we put the Columnstore index, we went from 17 to 5. Then we started reducing these B trees. We started eliminating them, taking them off, and we got performance down to 17 minutes, 5 minutes, down to 7 seconds. So one thing to consider, if you're going to put a Columnstore on, take a look at your existing B trees. Try out the performance, and if you can start eliminating them, you'll actually save space because you'll have less indexes, and you'll reduce your ETL time because you won't have to deal with that index maintenance of dropping and rebuilding so many. Yes? I don't think it does. No. It does. In this case, though, with so many covering B tree indexes, with the new Columnstore index, it wasn't generating the best plan. So if you start taking a look and removing them, you might actually see your performance improve. And that's because the optimizer was getting confused.
Just on the index tuning advisor, does it actually make sense for that functionality to exist in terms of recommending Columnstore indexes? The reason I ask that question is that if you're having to rewrite queries that are targeting Columnstore, they're not going to exist ahead of time. So will there be scenarios of queries coming in that would utilise Columnstore ahead of time before they exist?
I'm not sure I understand the question. If you could just try and...
Some of the examples you've shown
Yes.
earlier on, you've specifically been changing queries to actually utilise Columnstore.
Yes.
So in the environment where Columnstore indexes don't exist,
Yes.
those queries won't have been rewritten to target Columnstore.
That's
so
true.
What I'm kind of saying is, will the scenarios exist ahead of time in terms of the index tuning advisor to be picking up query traces to analyse and suggest Columnstore?
No, I don't think we have that in yet.
So would that be why it doesn't, that functionality doesn't exist? I think really what I'm getting at is...
It doesn't exist at this point.
Are you guys looking at actually adding that functionality to the index tuning advisor, or would it be pointless to add that functionality in?
Right now, I don't know, but you've given me something good to think about and take back to the team, but it doesn't do it right now. So eliminating unsupported data types. So when we shipped in SQL Server 2012 RTM, the Columnstore index doesn't work well with decimals greater than 18 digits, binaries, unique identifiers, datetime types greater than 8 bytes. This is on what's currently released in version 1. We are working on some of these types currently to get them supported. So your options are to omit the column, so don't include it when you're creating your Columnstore index, just don't put that column in, or to modify the column type to fit one of our supported types. For instance, you could convert GUIDs to ints. Ints would be better than strings. Reduce the precision of the datetime offset to 2 or less. So unfortunately, there's not a lot of options around this. You can either not put it in, or you can try and fit into one of our supported types. So here's the real key. How do we achieve the fast Columnstore builds? Because as I mentioned earlier, it does take 2 times longer than the B tree indexes to be built. It is fairly memory intensive. One recommendation I have is if you Bing Columnstore FAQs and you look up the memory management in there, it has a formula, and that formula will work well on telling you, look, my table is this size, this is how big I have it, how much memory do I need to build this? And this will help in advance so that you've got enough memory grants available. A couple things to be aware of is it only runs in parallel if you have greater than 1 million rows, because it's 1 thread per row group. So if you have less than that, then less than 1 million, it'll only be the 1 thread processing. Also, low memory throttles the parallelism, so the column segment needs to fit. So that 1 million row chunk needs to fit in memory. Some things to look at is to set your min server memory setting higher so that when SQL Server first boots up, it will grab more memory at that time, and that is a good opportunity to build the index at that time. You could also set your request max memory grant percent to 50. The default is 25. And you can also, if you can afford it, add more memory. And you can also look at the option, and this isn't a great one, but you could start omitting columns and not put some of these columns that you don't think you'll need into the Columnstore index. Now, a great place to look is this DM exec query memory grants. This is fantastic if you're troubleshooting. It shows you your DOP, so how many threads you're using. It shows you your memory grants, how much you requested, how much you used. It's very good at if you run into any memory issues to start digging into the problems. Yes. 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 Sorry, there's like a big fan here, so I can't quite hear you. You're saying if you had a... Okay. The supported types. Yes. Yes. It won't generate a Columnstore index. It won't allow that column to be in it. Oh, sorry, I couldn't quite hear you. If you don't put that column in? Okay. Yes, you will from the Columnstore index. Columnstore index, even if you didn't put that column in, will run in row mode, which is still faster than the other indexes running in row mode. But you'd have to take a look at the overall, how many columns did you put in there? And was that the key one, or was it just a periphery? And you'd have to see how it worked. Memory issues. This is a given, but the memory requirement is related to the more columns you have, the more memory you'll need. The more uniqueness of your data, the more memory you'll need. Now, if you're running this with a DOP 8, you will need more memory than if you ran this with a DOP 1. These are just all things to consider when you run into memory issues. And I just mentioned the query gets restricted to 25% even when the resource governor is not enabled. And if you do run out of memory and you hit these errors, 701 or 802, the workaround is to set the max DOP explicitly to 1. This will make it slower, but then you have a higher likelihood of it getting enough memory and running all the way through. Now, I'm just curious, there was at least a dozen people who said that they are using the Columnstore index and put it on a table. Have you had a lot of memory issues with building it? Yes. Okay. That is a problem. That is a known. It's like it's spilling over, and then it's. That's one option. That is one workaround. So now we're going to talk about segment elimination and how this helps with data reduction. So here was our segment, our query earlier that we used for an example. It was only taking 3 columns. But for each segment, in metadata, we store a min and a max for each one. And we put it in a system table called catalogs. And then when we have a query, the scans will go through and look at this min-max and only pick up those segments that fit. And the ordering, so you'll notice, isn't that nice in how it all goes 07, 08, 08, 09? Because it's based on the clustered B tree that was already placed on order date key that was on this table before we built the Columnstore index. So it's already kind of being ordered. And that helps when you have a query where order date key needs to be, greater than one of those min-max values or is tied to that. And that way your data actually stays ordered in those row groups. So in this case, we want the data greater than November 8th, so that top segment gets eliminated. And when you're scanning the data, that doesn't even get brought into memory. So only the bottom segments get brought into memory. So this further reduces the I/O. So there's some ways to verify your segment elimination. If you're doing some troubleshooting, or if you're trying to figure out how does this work, or if you're not getting the performance you were expecting, you can create an X event. It's a Columnstore segment eliminate. You can also have some trace flags, 646 and 3605, that will help with any kind of debugging issues. But the segment elimination, it can be very, very effective at reducing how much data you're bringing into memory. String performance issues. So earlier we talked a little bit about joining and filtering on strings. The issues are the string filters don't get pushed to the storage engine, and joining on strings is slow. So the recommendation we have is to try and factor the strings out to the dimension table. So in this case, license number is a string, and the recommendation is, hey, if you could make that an int in the fact table, and then just simply move it out to a dimension if possible. You'll actually get better performance on that. Forcing the use or non-use of column stores. So these are query hints. I used it when I gave my first example, just on ignoring the column store index. This is a great way to actually test out your performance. Put the column store index on, and then run it. Run it with the column store index on, and then try this and see how is your performance. And then the other one is just, it's an index hint. It works the same way as the custard B-trace. Is there any questions on loading or any of the workarounds that we've talked about, or any of the issues? No? Okay. Just give me 1 second. So I have one more example here of doing a trickle load. And I put this in here in case anyone had a question on loading using the trickle load idea. So we're just going to step through it, and it shouldn't take too long. Here we're just creating a table. It's called a fact table, and it's very simple. We're just going to insert 2 values. We're going to create the non-clustered index. And then just, that's what's in the table right now. It's just 2 simple values. And then we're creating this, which is like a fact table to do the trickle load. And we're just adding 1 row to it. Oh, sorry, that's user error. So here we're adding 1 new row, and then we're going to take a look at what the data looks like. So here originally was a 1 and a 2, but then I did the union all, which is right here. And that gave me, in total, it ran 1 and a 4. So I added the 1 and the 2, and then I added the new data. So that's an example, and it's a code snippet that's on the, if you Bing Columnstore index FAQs, it's in there to show you how you can do the trickle load as one of the loading options. So I actually left a lot of time for questions, but we didn't get that many. So in the summary, the keys to the fast processing are the column store index plus the batch mode. When you can get those 2 to run together, and the reality is you can't force your query into batch mode. The optimizer has to choose the batch mode. But those workarounds that I went through for in, exists, outer joins, and union alls, if you could structure your query in that manner, And I know some of the scalar aggregates was a little bit of a, complicated workaround. But if you can get the other ones to run in the sweet spot of the inner joins, the group bys, it will run in batch mode, and you will see some of your queries, you'll get amazing performance. And I've seen queries in the 15 to 20 minute come down to less than 10 seconds. Segment elimination is a great way to reduce the data. So this really cuts down dramatically on your I/O, and it'll bring less data into memory. Now the workarounds, right now the Columnstore index is read-only. Once you put the Columnstore index on a table, it in essence makes the table read-only. So we did go through 3 options. They have their pros and cons. We are working on an updatable Columnstore at this point, but those are the options that are available for what's released in version 1. And we are working on the updatable Columnstore and some of these workarounds. They're in progress. So future versions, you won't necessarily need to do these workarounds. The optimizer will pick the batch mode. Sorry, yeah.
The updatable Columnstore, is your feeling that would be a service pack release or SQL 2014?
That's a great question. We're working on it right now, and we're trying to figure out what's the best way to get it out. Ideally, we don't want to wait till the next box product. We want the customers who, took it and are using it now to get that. And a lot of people want that feature. So we're trying to figure out what's the fastest way and the best way to get it out. But we haven't made a call. We're working on it. We haven't made a call at this point. Yes? Is there any issue? Yes. To think about that. You've got the Columnstore index on one table that will run in batch mode. The temporary table, it actually depends on the size of that. Like the one that you put the Columnstore index on, that will run in Columnstore batch mode if you're running your query like the ones that we structured. With the temporary table, say that was huge, that may force it to spill and then go into row mode. If it was small, it could be like that example where we looked at the Delta purchase, and even if it was in row mode, the fact that it joined with the Columnstore table on that fact table that was executing so fast, that you'd still see great performance. Yes. It depends on the size of that temporary table. Yes. No. This is a limitation right now.
My initial question was, at what stage does it bring data into memory, and what considerations do you need to have when you have a lot of concurrent requests?
It's a good question. So I'm not sure about the considerations, but so I'm sorry, I don't know how to explain it, but if you want to talk offline, we can. I'm not really sure I'm understanding what you're...
You're referring several times that when you run the query, it brings the indexes into memory.
It brings the segments into memory when you're running it. It scans it and then brings those into memory.
Right, and do they stay in memory?
They do stay in memory, and then when it's finished processing, then they're removed. Yes. They don't necessarily have to reside. The key is they don't have to be in the memory. They're so small that they're brought in. It doesn't have to. It's not one of those in-mem database. It doesn't have to stay in memory.
It's the same type of data cache that we do for the bucket pool. We just have a different eviction algorithm. So we may be slower in the code.
Thanks, Tobias. Yeah. No, it doesn't. They are tied together. That is the new query execution mode, and it's tied to the Columnstore index. So it won't row with, it doesn't work otherwise. Yes?
If you have a large table
Mm-hmm.
with the spatial type, then you obviously omit the spatial type. If you run a query which includes the spatial
if you still have the special type in your query, then it will go to row mode, which means it will not be using the batch mode. It may still do the column store scan, but it will revert to row mode. So that's why, unfortunately, the more types you can get that fit our supported model and that you can get in the column store, the more they'll work in batch mode. Was there any other questions? Sorry, go ahead. No, it's not. It is not. And that is, again, in the column store FAQs too. It'll give you a full list of everything that's supported or not, and it is not yet. Pardon? Yes, that is not. That is not supported, sorry. Yes? Is there a size limit? I don't think there is a size limit. I think, like, if you're talking about how big could your table, your row be, that it can still work with this.
For the types, there are some bytes, which is set for index. And probably using the primary keys is 99 bytes. Limitation about column storage.
For how many bytes you can have in one column?
No.
Or across the whole?
Across the whole index.
I'm not aware of there being one, but again, I can look, or you can look under the FAQs and see. Is there any more questions?
What is the, if I, when will this benefit of Columnstore index come in compared to data sizes? Let's say that if I have 10 million rows table and 1 billion rows table, then does this 10 million rows table benefit also from column index? If compared to the P3 index.
So you put a column store index on your 1 billion row?
Okay, let's say 10 billion.
10 million?
Yes.
That will benefit from the column store index. And you're also going to put it on your 1 billion?
No, that I understand.
Oh, yes, 10 million will benefit.
There's an even smaller table coming, OS coming much faster than using the standard P3 indexes.
So your question is, if I'm hearing you correctly, is what size does it start working well for the column store index, and what size does it not?
Yes.
We don't have a size limitation, like all of a sudden it'll start performing better. But at plus a million, you will see the benefits.
Okay.
You can build it on the table less than a million, but definitely past that, you will see the benefits. And again, the example I talked about earlier, that query that went from 17 minutes to 7 seconds, that was a 2 billion record table. Okay, that actually oh, sorry, go ahead.
You mentioned that there is only how many memory needs actually the server.
Yes.
Because it's very memory intensive.
Yes.
Can you tell me where to find that kind of formula?
Yes, it is. If you Bing the column store FAQs, it'll be the first item that comes up. And then if you go, I don't know, about 2/3 down that article, it talks all about memory management, because it is really important. Otherwise, you'll have memory issues when you're trying to build the index. And it gives you a formula. I should have included on here. It gives you a formula that kind of lays it out. If you have this many bytes per column, this is the size of your row, this is how much memory you should reserve. And it kind of lays it out so that you know in advance. And if you look at that, I mentioned it, that EX, that special query that shows you the DOP, the memory used, the memory grants, memory required. It's very good at debugging if you run into memory issues. Yes, it is right here on the bottom. The exec query memory grants. It's very helpful for anything related to the memory around building the column store index. In general, it's helpful, but for the column store index, where they might run into some memory issues, it's particularly good. Okay, that actually concludes the session. I'm going to be here for a while, so if anyone has any specific questions, feel free to come talk to me. Thank you.